Here are the questions I saw, or heard actually, in the other class. Okay, guys, shh. If this is the inverse sine, why don't I get a cosine? Why isn't it inverse cosine? So I redid it. I said, let's do it again and see why it is. This is y, and I want to find dy dx. So I'm going to add another page. So y equals the inverse sine of x. Okay, so I don't necessarily know what the derivative is. I do because I've memorized it. You want to memorize it. But if you're on the exam and you've forgotten what it is, you can always work it out. So if I solve for x in terms of y, remember, this is an angle. Yesterday I called it theta. Today I'm going to call it y. It doesn't matter. This means that the sine of my angle is equal to x. Okay, Alexis? Remember, y is an angle. Let's draw the triangle that goes with that. So here's my angle y, and if the sine is x, which is x over 1, what's this side? X, and this is 1. Okay, girls? Then what's this side? Careful. It's going to be the hypotenuse squared minus the length squared. 1 minus x squared. Okay, James, put the phone away, please. Okay. Now, let's take the derivative of my new equation. So it's the derivative with respect to x. I'm doing it implicitly because I don't know what the derivative of the inverse sine is. And do I get a cosine when I do this? Yeah. So I do get a cosine. I get the cosine of my angle times the derivative of the inside function. It's just the chain rule. And by now, most of you are catching on to that. It just takes time. And by the end of the day today, I will be really good at this stuff because I've done it so many times today. And that's equal to what? What's the derivative of x with respect to x? 1. Solving for dy dx, I get 1 divided by the cosine of my angle. I do get a cosine in there. Now be careful with this negative 1 symbol, because that means inverse. Some of you think that this means this, or this, sine of x to the negative 1. They are not the same thing. Okay, so that's a problem with mathematics, at least to me, is they use that symbol 2 different ways, and you have to be able to interpret the correct way. So that's a problem. So this is not the cosecant or anything. Now, look at my triangle. Colin, what's the cosine of y? Because then I'm back to where I want to be. Cosine of y is the square root of 1 minus x squared over 1. And that's the derivative of the inverse sine. And that's what you missed yesterday. I feel like we're in Glee. You don't watch the show? I do. And that's what you missed. Okay, you don't get it. That's okay. I'm going to give you this in a second. Yeah. Yeah, that's how I derive it. We're not going to derive it every time. We're going to memorize it. Okay, Noah? Jack? You have it memorized? Yeah. Because what we're going to do is we're going to find antiderivatives. And when you do antiderivatives, you're going to have to know that one. Okay, are you ready to go back? Not if I am given an antiderivative, I need to recognize it. So dy dx is equal to 1 over the square root of 1 minus x squared. Okay, let's do the derivative of the inverse sine of f of x. Okay, girls? What's this going to be? Okay. Now, I'm not going to put in x. I'm going to put in what, Noah? F of x. And then what do you have to do? Chain rule times the derivative of the inside function, f prime of x. Now, do you want me to go and derive the inverse tangent one again? Or do you want to just know it? Okay. New page. Let's do the derivative of the inverse tangent. So y equals, and why does this one not have a square root in it? Okay, this means, remember, y is my angle, Alexis. Do you remember this answer? What is this one? No? Okay, that means the tangent of my angle is x over 1. Should do it with me if this is confusing. Okay, here's my angle. Tangent's x over 1, so this is x. Okay, you guys in the back? This is 1. What's this side? What's the square root of x squared plus 1? There is a square root. There is a square root in this one. That's correct. Leg squared plus leg squared is hypotenuse squared. Okay, let's take the derivative. And why do we not have a square root in here? Because of this. What's the derivative of the tangent of y? Secant squared times the derivative of the inside function, dy dx. If you don't have a dy dx, then you're in trouble. And what's the derivative of x with respect to x? 1. So solving for dy dx, it's equal to 1 divided by the secant squared of my angle. I'm going to square that. So that's why the square root goes away. So what's the secant of y? Now the cosine of y is 1 over the hypotenuse. So secant is hypotenuse over 1. So that's equal to what? 1 over that thing squared, which is just x squared plus 1. And the inverse tangent you're going to see a lot. X squared plus 1. Now, if you were to find the derivative of the inverse cosine, we would rewrite this. The cosine of y is equal to x. What's true about the derivative of the cosine? Positive or negative? It's negative. Because when I just take the derivative here, so the derivative for the cosine is the same as the sine, except it's negative. The derivative, I said that wrong. Derivative of the inverse cosine is the same as the derivative of the inverse sine, but it's negative. And it's because of this cosine right here. Negative sine of y times y prime equals 1. We are not going to learn the secant and the cotangent and cosecant. I can do those. So cross them off your sheet. Okay, ready? So this is 1 over. Yes. Now what we did yesterday was we also reviewed a lot of inverse trig. That's all. So what's this one going to be? This is going to be 1 over 1 plus, but it's not x, it's f of x squared times f prime of x. That's with the chain rule. That's the derivative of the inverse tangent function. Right. Now on your test on Friday, I gave you out a multiple choice packet. And if you do that, that's I think either 97 or 98 exam, those solutions are up online, you will be well prepared for the test on Friday. Who else was gone yesterday? So I highly recommend that you do these. Tomorrow and Thursday will be review days. Okay? We try to pull as many AP problems as we can. Okay. Now, for the hard material. That was easy. Are you ready for the hard material? Now, you have to focus, Brian, and put your phones away because you won't get it. But by the end of the class, if we do enough problems, you should. Okay, girls? We are going to do the derivative of the inverse of a function. So first I have to get some things clear about what's what. The hardest part for me are the x and y coordinates. Because which one are they talking about? The function or the inverse? There's a couple ways to look at inverses. And this is all you have on there, but we'll do some examples. If I have y equals f of x, that is its own function. If I solve for x in terms of y, what's the variable here? It's y. That's still the same function. That would be me giving you the y coordinate, tell me what the x is. Your 84 calculators will not do that. Your Inspire calculators will do that. Either one. Either one. They've redesigned with the new operating system so you can do that. But we're not going to do that. This question is, hey guys, if you don't pay attention, it's going to be tough. This is the derivative of the inverse function for y equals f of x. And this is the x-coordinate of the inverse function. I find this confusing, but we're going to get it. So first thing I'm going to do is I'm going to draw a function, maybe. And I'll just draw any old function. It doesn't really matter what I draw. And there's my function, y equals f of x. Now, do you remember how to get the inverse of that function? It's a new function. This one over here is the same function. Give me the x if I give you the y. This is a new one. Remember you reflect over y equals x? Do you remember that? And so if I do that, it kind of looks like this. And what's true about your pairs? If this is A and B, what happens over here? They switch. Now, what this question is asking for is not the derivative of the function. It's asking for the derivative of the inverse function. So I'm going to draw a line. Here's the tangent line for the original function, and I want the slope of the tangent line for my inverse. Now, maybe you can see the relationship there, maybe you can't, but we're going to come up with it. Okay? Well, this is the easy part. So I will go to a new color for my inverse function. Okay? So let's go to blue. And I will keep things color-coded as much as I can. So my original function is y equals f of x. How do we find the inverse? What do? We switch x and y, right? So I'm going to make the y x. X equals some function of y. Sometimes I can solve that equation for y. Sometimes I can't. Now, this is a problem they've been putting on the exam lately. In 2007, they first did the intermediate values theorem, which the students didn't know what to do. These are 9-point questions. And then they hit them with the mean value theorem, which students didn't know what to do. Then part C, the kids felt good because they could actually do that part. Then they got to D and they asked for the derivative of the inverse function. And it was like, oh my goodness. The average score out of 9 points was 1. It was a disaster. We will do that problem. I promise you. So I now make sure that I teach this and try to teach it as well as I can. By the way, this is most time I can just come here and teach the topics that I've been doing for 20 years. This one I have to prepare for every year. It's just tricky. That's all. This part's the easy part. I get this pretty well. So what we're going to do is take the derivative of this. It's going to be the x and y coordinates that cause us the problem. So I'm going to take the derivative with respect to x, the derivative with respect to x, and the left-hand side is always going to be 1, because I'm always going to have x over there all by itself. So what's the derivative of x? 1. equals f prime of y times the derivative of the inside function. Call it dy dx or y prime, I don't care. So solving for dy dx, now the blue is all the inverse. That's f prime of, whoops, I don't mess it up, 1 over f prime of y. Notice the derivative is the reciprocal of the other derivative. If you look at the picture, which isn't great, if you look at the one in the book, it's better. You can see that there's a relationship here. These are reciprocals. The hard part is figuring out which point you put in, the x or the y. Because this is all in blue, this is the y coordinate for my inverse function. So I didn't have a problem doing this on the exam that year. I didn't remember the theorem, so I just did what I did right now, and we're going to do that. We'll do a couple examples, as many as you need. We did several in the other class. We actually went into the homework and looked at them, because they start in about 43. Now, when you do 43 and 45, you can solve for x in terms of y. You can do that. Or y in terms of x when you switch them. But I didn't do it that way. Okay. So let's do a problem. Now remember, this is the hard part. That's the x-coordinate of the inverse. If that's the x-coordinate of the inverse, then it's the what? Of the original function. It's the y. That's the trick. That's the trick. Okay, so here's f of x. I'll put my original function in black. That's not working quite right. No, this is my other book. And we want to find, and I'm going to change colors here, the derivative of this function, of the inverse function at 3. That x or is that y? Of the inverse. Remember what this was? This is the x for the inverse, right? So let's write down the ordered pairs. This is x comma, well, it's 3 comma, whatever the y value is. So if I go back to the original function, what do I do with x and y? I switch them. So then this is my x-coordinate here, and my y-coordinate will now be 3. I think that's tricky. This is the x-coordinate for the inverse, which is why it's in blue. So that's the y-coordinate of my original function. And some of you are going to say, well, I can't find x. Some of you are going to say, yes, I can solve a quintic equation. I don't know how you do it. Only through the 4th degree polynomial can they be solved algebraically with a guarantee. Yes. Because this is on the inverse. So this is my inverse, and this is my original. And what happens to the coordinates? They switch. Morning. That's the x value of the inverse, which means that's the y-coordinate of the original. We'll do several of these. No, I haven't done, no, this is the function black. I haven't done the inverse yet. Can you solve? Well, we'll do that in a second. Noah. I need to find the x-coordinate, because I need to find this y-coordinate here. I need the ordered pair. They gave me the x. Sometimes they give you both. Sometimes you give you both. I need the ordered pair. Because when I do the derivative of the inverse, I'm going to evaluate it at the y-coordinate, because we'll go back here, remember? That was y. You'll see. Just patience. Now, the question is, how do you find x? Yes, you can. Not a graphing calculator. How about guess and check? Well, not too much. What if x is 0? Does that make that, can I get that to work? I get 3 is equal to 1. Nope. What's the next easy value to check? Does x equal 1 work? Yes. So they're going to give you either 0 or 1. They'll give you something either you can find or you can do easily. But it's just guess and check. Okay. So this x coordinate will now be 1, comma 3. So on my inverse, what's this ordered pair? 3, comma 1. Now I can forget about the original function. Well, I got to inverse this first. So how do you find the inverse for this? What do you do with x and y? Switch. So this is going to become x equals y to the 5th plus 2y cubed plus y minus 1. That's a new function. It's not even a function. It's just new. Because I don't believe that's a function. I'd have to look at that graph to know for sure. But it doesn't matter. I can still find the derivative. So we're going to take the derivative with respect to x, because that's what I want, dy dx. So I'm going to take the derivative of every term. And then you just do that. This is easy, right? Because this is a polynomial. I know how to do that. It's just the power rule. Whoops. So the left-hand side is 1 is always 1 equals the derivative of y to the 5th is 5y to the 4th times what? You want to use y prime or dy dx? Okay. dy dx plus, what's that going to give me? Times dy dx plus dy dx. What's the derivative of this 1 over here? It's 0. I factor out dy dx, and I'm left with 5y to the 4th plus 6y squared plus 1. This is algebra. Solve for dy dx. Just divide. So dy dx, remember, it's the reciprocal of the original derivative of the original function if you think about it. Now, you can memorize that, but again, you still have to figure out which point of your ordered pair you're going to put in there. And that's why I like to do it this way, because to me, it's clear. I want which one, x or y? It's the blue y, isn't it? I want the y coordinate from the inverse or the original? Inverse. And what was the y coordinate of my inverse? 1. That's how I do it. So you're going to evaluate this at y equals 1. So we're going to do it. So dy dx is equal to 1 over 5 plus 6 plus 1, or 1, 12. That's the slope of the tangent line at that point for the inverse function. What's the slope of the original function at that point? It's 12. Right, you needed to have the 3 to find out what the other coordinate was. And so if I found this derivative here, you still have to understand, this is the hard part, is this 3 is not the x coordinate of the original function. It's the y. This is the x coordinate of the inverse, so this becomes the x coordinate, the y coordinate of the original function. So you could take the derivative and evaluate this at x, and x turned out to be 1. Except for the tangent. No, not tangent. Yeah. I did that today. I did. Okay, let's try another one, and then we'll go to your book. How about that? Now, it's going to be guess and check. Okay, so this is example 2. I don't think I labeled the other one. Should have. What I like about this book is there are many examples. Many problems with it. We are going to find the derivative of the inverse. I'm going to keep it in blue. So it's the inverse at 1, I think. Yep. I want the derivative of that. No, they're all the same. Once you get it, they're all the same. Because I gave it to me. That was the question out of the book. I want the derivative of the inverse. Some of you prefer to do the original function and then do the reciprocal, provided you know it. But, that's one more thing to memorize. So I don't. Okay, this is which coordinate of the inverse? No, the x. So it's 1 comma y. So of my original function, is this the x or the y? It's the y. So 1 equals the cosine of something plus 3 times the same something. You see why it's not the x coordinate, it's the y coordinate. That's if you get, because they gave me this one right here, and that's the x coordinate of the inverse. That goes there. Yes. What's it? X. Well, you could try 1. Try x equals to 0. 1 equals the cosine of 0 plus 3 times 0. What's the cosine of 0? 1. So my ordered pair here is 0. No, x is 0, y is 1. So my new ordered pair, and now I can ignore the original function, is what? 1, 0. I know, it's confusing. If I do it slow enough, it's not bad. This is the one lesson I said that I really have to come in. There are probably other ones, but this one in particular is one I have to really think about before I come in here. Ask. You know that the x coordinate of my inverse is 1, then that will be the y coordinate of the original function, and I did guess and check. You can't solve that algebraically. I can if I do my Taylor polynomial, but that's beyond us. When are we going to do that? Next year. Okay, ready? Okay, let's get the inverse function. Well, the inverse of this function. This is going to be x equals the cosine of y plus 3y. And now what are you going to do? Because we know how to do this. Take the derivative. So it's d dx. That should be the easy part. My problem is always getting, which one do I put in where? And you know what they do on the multiple choice part of the exam? They evaluate the slope at both places, the x and the y. So you're going to have a 50-50 chance on your guess at best, if you just guess. Okay, so this is 1. What's the derivative of cosine y? Negative sine y. Oh, I thought I was chatting for times the derivative of the inside function, dy dx, plus 3 times y dx. And then I'm going to factor out dy dx. The same every time. So it's minus sine of y plus 3. Solving for dy dx. 1 over minus the sine of y plus 3. Now all you have to do is evaluate it. And you're either evaluating at 0 or 1. But remember, this is the y coordinate here, isn't it? So I go to my inverse, and it's the y coordinate. So where am I going to evaluate it? At 0. Guaranteed you'll see an answer with it evaluated at 1 in the exam. Oops, 1 more. So this is going to be at y equals to 0. What's the sine of 0? It's 0. So it's 1 over 3. If you don't remember what the sine of 0 is, do a quick sketch, and you'll answer your question every time. On the math team meet yesterday, we had a trig question, and if you did the unit circle, you were kind of in trouble. If you understood the triangles and the quadrants, it was a piece of cake. It was very easy. there was a trig question. They all did well. No, we're in second place to Izetta. Always, always, always. I know, I want that trophy. Darn it, I've been doing this for a while. I want that trophy. No, but this is the best we've ever done. Second place. We're in second place. For many years, we were fourth. And last year, we were third. Edina beat us out. But we're beating Edina. Probably about fourth. We didn't go to state. We'll go to state. Mm-hmm. No, we still have 3 meets left. Okay. Let's do some problems out of your homework. And there may be questions before this. I don't know. Okay. Now, I'm sorry I have meetings tomorrow morning. I can be here after school for a while tomorrow night. Tonight, I have an iPad training, so I won't be here because I think it goes straight till 3, and then I've got to do academic recognition. Okay. And I'm here Thursday morning, and I'm here Friday morning. Now, don't be like me and blindly look at the problem and go and do it, because that was silly. It says, given the function f, find the slope of the line tangent to the inverse function at the specified point on the graph of the inverse. I thought that was the point on the function. Does that make that true? Is 4 equal to the square root of 2? No. So when you do that wrong, that causes everything else to be wrong. So that is the inverse one. So we'll just keep that in blue. So what would the point be on the original function? 4 comma 2. They did in a sly way, if you don't read everything, which is what I did, it says at the specified point on the graph of the inverse. I didn't read that far. So then, of course, I got it wrong. Now it's easy. Okay, this is your inverse. We're going to be in blue. And now, could you solve? Let's switch these. This is x equals the square root of y. Could you solve for that and then find the derivative? Could you solve for y? Well, what's y equal to? Yeah, x squared. It's actually easier, but then you got to get the right value. So let's just do this the way we've been doing it, so we get some practice anyway. Do it either way, but you'll have to switch your ordered pairs, and I don't even want to go there. It's 1 equals, well, this is going to be y to the 1/2. What's the derivative of y to the 1/2? 1/2 y to the negative 1/2 times dy dx. If you don't have a dy dx in there, you're in trouble anyway. Okay, so I'm going to have 1 equals 1 over 2 square root of y dy dx. Solving for dy dx is equal to 2 times the square root of y. What's the y I'm going to put in there? Notice I'm all blue. What's the blue y? 4. Works every time. The hard part is sometimes it's hard to know which value you were given. Was it x? Was it y? Was it the original function? No. So this is 2 times the square root of 4, which is 4 of them. Right. Notice I kept it all color-coded. That's why I did that. That help? Okay, if you're colorblind, it doesn't help, but there may be shades. Can we do the next one? We're going to do number 45. Now, there's some charts down here. There's an example in the book of charts, and maybe we'll do it first thing tomorrow. But make sure you do those, because I've seen that often on the exam with the charts and the derivatives of the inverses. Of course, it makes it hard, you know. Okay, let's do 45. Are we ready to go on? I'm at page 221. Yeah. So you could solve for y here once you invert it, because it's doable, but you know what? It's just as easy just to do this. Now, this is the coordinate of the inverse. So this is 36, 4. So you didn't have to figure out what the other value was, because they gave it to you. So what's the original one? Just make sure I have all my ordered pairs here. 436. And then you could check. Does that make sense? You put in 4 here, it gets 6 squared. That's 36, so that works. Okay, so let's find the inverse. You see how they're all the same now. So x equals y plus 2 squared. And then we'll take the derivative with respect to x. Not to mention the fact that this slows me down a little bit. So it's d dx, d dx. Left side's always 1 because it's always x by itself. So 1 equals, well, what's the derivative of that? 2 times y plus 2 to the what? First power times the derivative of the inside. What's the derivative of what? dy dx. Remember, if you don't have a dy dx, you're in trouble. Y is some function of x. I can actually solve for it, so you have to use the chain rule. So what's dy dx equal to? 1 over 2 times y plus 2. It's the y coordinate. It's a blue y. So it's 4. And you know they're going to give you the other answer. Yes. It's the y of the inverse. Notice once I changed over to blue, I'm going to stay with that. So this y here is the same y as up there. So now I'm going to substitute it in. And we can do one more here. Yes? Nope. We were given this. So we were given the y value. I mean, they gave us both. So we can do the next one. We have to do a little bit of work. This one's not as easy. Well, I don't know if this is easy, but. So what's the answer? 112. Strongly recommend, if you need to do evens, but then you won't have any answers, that you do more. Okay, so 47. It's kind of like what I did to begin with. Are we ready? Do you have a question? No. That's it. That's the end of the chapter. We take a test on Friday. We have 2 days for that. No, we don't have time for that. No, you don't. Yeah, we'll do that tomorrow. We'll do it tomorrow. Oh, I didn't do this in color, did I? Oops. Oh, I know what I can do. Yeah. I don't. Thank you for reminding me. Okay. Okay, you guys ready? I keep it all. Once I switch over to the inverse, that's all matches. I don't want it to be confusing. Because this is the x coordinate. This is the x coordinate of the inverse. That's the x of the inverse. Now, when I do the derivative of this, let's not find the ordered pairs. My derivative will be in terms of y, always. And so I need to know what that y is. So 3 is the y here. Okay, you guys? The blue is the inverse. The black is the original. What? They will not color code it. And you may not bring in colored pencils. I don't know why. Or highlighters. Okay, what's x? I don't know how to solve that. You're right. But is x 0? Guys, is x 0, Noah? What is it? 1. It's always going to be nice numbers like that. So then this ordered pair is 3 comma 1. Now that's my x and y. Let's do our inverse. X equals y cubed plus y plus 1. Now when I take the derivative, the x's are going to go away, and I'm going to have y's in it. So which value am I going to use, the 3 or the 1? The 1. Took all hour, but yes, once we get it, it's easy. But this is something that I have to review every year, which means that in the spring, we have to review it. Oh, it's your homework problem. I have to write it down. Do you want to come up and do it? What's the left side? 1 plus dy dx 0. Factor out your dy dx. Which is 3y squared plus 1. So dy dx. This is why I like this method. Because it tells me which letter I want. I want the y of the inverse, which was 1. Mhm. So this is this one right here. So you put in the 1. So dy dx equals 1 over 3 plus 1, or 1. You might need some more practice. You know what? It doesn't hurt you to do the problems again because you have them written down correctly. Now, were there other questions out of the homework? We still have about 10 minutes. What do you mean you're done? I'm the one talking bell to bell. Casey.